y-axis now.
I know, you're gonna.
Okay. Well, now we have this hard thing. Now we have these hard things.
Oh, come on.
Axis and theta axis.
Did I leave off? Oh, whatever.
Or wouldn't it be like that?
Okay, guys. So we are starting polars today. Polars are different. They're a different way of graphing than what you are used to. So you've been graphing in the rectangular coordinate system, the XY coordinate system. Now you're going to use the polar system, which is the R theta. So instead of an XY, you now have a radius and an angle that you will graph. Okay? So you're used to plotting, say, the point 3, 4. So you'd go 1, 2, 3, 1, 2, 3, 4. Oh dear. And you'd plot a point, right? We all can plot a point. Yes, baby, I hope. So in the polar coordinate system, I might give you the point 4 pi over 3. Okay, so the 4 is the radius, so you're going to count out 4 rings. We still start on this, essentially what you would think of as your positive x-axis. You start over there. So you count out 4, and then you have to find your angle pi over 3. They aren't all labeled for you. This one is pi over 6. Pi over 4 would be in between. It didn't get a line. Pi over 3. But you're just, you know, the labels of your unit circle, that's where you're going. So 4 pi over 3 is the point 1, 2, 3, 4. Right there.
Interesting.
This is a day where you don't really want to blink a lot. You just want to pay attention. Ben?
You have, it just looks like a bunch of big little tiny rings.
So can you see it on your paper? Like, yeah, like, so there's a ring, there, yeah, those are all rings along here. I'm sorry, what? Some grids we give it to you, some we don't. It's there, whether it's drawn in or not.
I should get at least 1 star on that board.
You can do it. No, I was copying. You can definitely do it. You can do it, Adam. What? I'm sorry. Kind of, yeah. Essentially. You what? Unit circle, but we're plotting points on it.
I will see them together.
All right, guys, we are going to practice plotting a point. I drew in the line where pi over 4 would be. Do you guys see where it's going to be? Like this is pi over 6. So draw in your pi over 4 line. Try to plot 6 pi over 4.
How is the same as any
What?
What?
Plot it first. Does anyone else get a little bit dizzy when you count your rings?
Yeah.
Okay.
Yeah.
Yeah, I'm like, oh, okay. Wow, that's like moving.
Yeah, Shauna.
Good plot.
Oh, wait.
He's taking his test. Okay, everybody good with plotting 6 pi over 4? Okay, so that was counting out 6 and then going this way pi over 4, right? What if I traveled this way to get there? That would be 6 comma what angle? Yes, -7 pi over 4.
Great.
You went backwards. So I could name this point in a bunch of different ways. I might ask you to name it several ways. Or I might say plot it and give you different things. So you got to be aware of what all of these mean. But they all mean the same thing.
How many possible options?
Well, there's infinitely many because you could go around and around and around.
Did you do 9 pi?
Yes, that was the next one I was going to write is 6 9 pi over 4.
Does the x value change?
No, that's what I'm going to show you. The x value can change. So let me erase this. So that was +6 for our r value, right? What you think of as the x value with the r. What if I did -6? Where does that start? Yeah, you can actually start over here. 1, 2, 3, 4, 5. So then you could go a couple of ways. You could go backwards one way. You could go forwards the other way. So let's see, what would those two be? What if I went backwards? That's the small one. Yep, -3 pi over 4. +5 pi over 4, yes. Do you see it? Not do you like it, but do you see it? Ben?
How can you just start at the beginning? How to start?
I don't do well.
Keep understanding.
Wait, this
What?
Not like you don't care if it's not there.
Oh, I mean, I hope you like it, but if you don't, you don't. That's okay.
Exactly.
how can you start at -6?
Because it's negative. Right? Think if you were plotting an XY point, couldn't you plot a negative point?
Going back.
How's that like a equivalent? It's like
It's along the straight line.
I moved that. Like, what if I plotted -3, 4?
Got this.
You can go left, correct? So a negative radius means you start over here instead of starting over here.
but like -3 requires
Negative what?
-3 comma 4.
No, it's not. But I'm saying it's a negative x value. Here you have a negative r value.
Are you just basically changing one of the values?
Yeah, and then we're figuring out what the angle has to be to make that negative r value end up in the same spot.
Okay, so you end up at pi.
It ends up here, but you can label that point in a bunch of different ways. Think when we did coterminal angles, right? Pi over 4 was the same as 9 pi over 4, was the same as -7 pi over 4, right? We're doing that again, but we're throwing in a radius.
Pi over 4, you still kind of counterclockwise to get there, but then the negative would go in.
So you do the radius part first. So if I see -6, I need to go out here first, and then I travel my angle from there.
Is there like an easier way to remember like which way negative goes and which way positive?
I mean, negative is always this way, right? So you're starting over here, negative still means that way. Okay. If you like formulaic ways to think of these points, you can do r and then theta plus or minus 2 pi k. Or if you do negative r, then it's theta plus or minus pi k. I think it's easier to just think because I know my circle very well. R is what you're given. Like in this problem, it's 6. Well, if you're given the point, you know r and theta. Yes. Like how to find all these other names for it. Okay? Yes?
Do you start at like -6, comma,
What do you mean -6 comma pi?
6 pi over 4.
6 pi and -6 0 are the same point.
Okay.
But different than this point. Okay, try to plot some points for me and try to name other names for them. So plot A, B, C, and D, label them, and then come up with some other ways you could name those. I'll give you a minute here. Talk to each other, see if you agree. Just no. Okay, no talking. Got it. Okay.
Rosanda, you want to talk to Rosanda?
They all looked at
When you're ready to check, there's where the points are.
What did that one?
Good job, you plotted well.
So if we, on our test, like, do we, like, will this kind of stuff be in our test?
I'm probably not going to have you plot a point on your test because we're going to get to much more involved things than plotting a point. But if you don't know how to plot these points, you're not going to be able to graph the other stuff. You know, it's like you got to walk before you can run.
So like if we're like off by a row, you know what I mean?
Oh, no.
Because I'm like,
I'm
miscounted.
with you. Like I get like lost in the rings, and I'm like, wait.
The rings of
It does feel like we should incorporate like Lord of the Rings into this lesson somehow. Yeah.
What if you made our test Lord of the Rings?
Don't, please, God, stop that.
Shades of no.
Do not do that. You made that test. I beg you to be long for no reason.
It would be long, and you'd have to learn like a new language in the middle. And yeah.
That's an AP exam.
Hopefully, Gandalf is not going, "You shall not pass" in the middle of your test. Right? We don't need that.
Like in Finding Nemo,
We switched to Finding Nemo. Okay.
Martin, he has to go through the Ring of Fire.
Yes.
When was this?
Or no, it's Nemo.
It's Nemo. It's when he's in the dentist office, right?
Oh, Gil and Sherry, I think they made him go through the volcano.
Yes.
And that's the Ring of Fire. So we should make it Finding Nemo.
I like it. How we doing, guys? Do you have your labels, or you need a minute? Minute. You need lots of minutes. I'm just gonna write some. I'll do like one positive and one negative. So guys, write with a, let's say this, write with a positive R and write with a negative R. Okay?
Oh, it's too late for that.
Well, add another. You can do it. There's still multiple options, but
I'm gonna strain my eyes.
the rings are just too much. Oh, wow. Guys, I don't, let alone, I can barely copy this for you. Like, I have access to a color printer for you guys. What?
That's what we're gonna get you next. Get your push.
For C?
Yeah.
You can do, yeah. Yeah. Or negative 2 pi. Okay.
Maybe the school like running out of paper.
There's definitely a rumor of that.
Have you noticed that?
I have had access to paper when needed, so no, no.
Apparently, like each.
I also don't print a lot, so like I don't copy a lot. This will be like the most I copy for you this unit, or skill, or whatever we're calling it.
Like Miss B thinks that I can bring her paper.
Really?
Who's saying that?
Apparently, like the science teachers are like low on paper. Yeah.
Math is going strong.
Doing just account.
Apparently, the rumor I heard is
That is accurate. Well, like, school gets like discretionary money to spend on different things, and it like all went to furniture, so there's less money for paper.
Yeah, they have in the library, but they don't let anybody in.
You're not. Are you banned from the library, Maddie?
No.
Oh,
I'm
okay.
talking about how they like only let a certain number of people in.
Well, you need passes to go to the library.
Do you guys want to have class in the library someday, just to be in there?
I think we destroy the library so nobody can use it after.
Gosh, everyone's so excited.
Let's do one of the days where we're in the half month we're not doing anything. To go reflect.
Oh yeah, should we go to the library in June, guys? Yes. Okay, perfect. All right, guys, let's go through these. For A, I would do 4, maybe negative pi over 3. Yes. And then negative 4, I would think 2 pi over 3. You could also do negative 4 pi over 3 if you like negatives a lot. All right, 4 negative pi over 4. Did you do 4 7 pi over 4?
Yeah.
All right, and let's see, negative 4 3 pi over 4. Are we on a roll, guys?
Yeah.
Okay. Negative 4 0. You could do 4 pi or negative pi. Negative 4 2 pi. Sure.
Could you do negative 4? Or no, it has to go around.
You could do negative 4 negative 2 pi. All right, negative 6 pi over 3. I'm going to do 6 4 pi over 3. Or negative 6 negative, what, 5 pi over 3?
Let's go.
Yeah? Negative 6, 7 pi over 3 would also work, yes.
Positive, yeah, that's what I did. Positive 6, negative 2 pi.
Positive 6, yes. It would. Lots of options here. Fun for me to grade, guys.
Right, yeah.
I'm like, wait, I'm like,
Someone should pull up and do like 15 loops of the circle and then do it or something. You do crazy big fractions.
this is why I'll usually give you a window. Like your answer has to be between fun ruiner there.
Like 10,230,000.
All right, we okay so far, guys? Okay. So far, so good, right?
I am waiting for the stop understanding.
Nothing.
Stop math on tests.
Why can't I take a nap anymore? I'm gonna go to the bathroom and take a nap.
Just make sure no one else is in this stall with you. Man, you good?
I promise I am not overdosing. I'm just tired.
Yeah, because we got to keep moving, okay? All right. So you now know how to graph both rectangular and polar. You can plot points. We're going to convert. So equations can be written as rectangular equations, like with x's and y's in them. Or they can be written as polar equations with r's and thetas. We can also convert our point, an xy point. We can rewrite it as an r theta point, okay? So,
500.
Wait, this is more formulas I have to remember.
not really. I mean, a little, but they really make sense.
Okay.
Like, it's not like an arbitrary where you're like, what? Why are all those
It's like
things
some
together?
difference and like double.
Yes. Yeah, like that.
Oh, nice.
Oh wait.
Do you agree?
Yeah, that.
We can do this, right? And the x, y, and r, that all makes sense from your other stuff.
Where's that?
How many timers do you have set?
Too many. It's a lot to manage. Thank goodness there's only 2 people like yourself. Okay. We're good. We know the theta, we know the r. This is all familiar from all of the trig we've done. Okay. If I said cosine of theta equals, what would you tell me? X over r. See, you know things.
Good job, It's literally what I just said.
So, would you agree that r cosine of theta is equal to x? Okay. We're going to put that in this little box then.
This is why you use art when you're explaining what the different. I think I remember that one. The tree does some of that stuff.
All coming together, isn't it? All right, what if I asked you sine of theta?
Y over
Okay, y over r.
R.
So would you agree r sine of theta is y? Okay. With me so far, right? Okay, so now we're going to use that so I can turn a polar point into a rectangular point. I know it's what you've always wanted to do, is turn polar back into rectangular. Yeah. Yeah.
Wait, yet? No, we don't get my class, right?
No, you don't need to calculate this. No. I might say, what would this be on our thing? Stop whining. No, this is not bad. Okay, so guys, the point 6 pi over 6. The 6 is your r value, right? That's the radius. And the pi over 6 is the theta. Yes? Okay. I'm just going to plug these into the x and y formula and figure out what my points are. So x is going to be 6 times cosine of pi over 6. And y is going to be 6 times the sine of pi over 6.
Oh, I see.
No, what's the cosine of pi over 6?
I don't want to think.
Root 3 over 2. Oh, you need to. The beginning, when I was like, you need to know this, were you just like, I'm going to not, just to see if it really matters?
That's exactly.
We're testing
She
the water.
might be lying to me.
I wasn't in the class.
So wait, can you put the 6 on
That
the
makes it
top?
hard. Yeah, it's like 6 over 1. So if I reduce, what do I get?
So then, do we actually have to write the graph out?
Mm-mm.
Hey, were you cheating, bro? I can't believe it.
Yeah, I'll cheat on the one that doesn't count as a grade.
That one though.
It's a good strategy.
Right.
All right, more time for these guys. Okay. And what's the sine of pi over 6? 1/2. So if I write the ordered pair, I think I left you guys more room than what I left myself here. The x is 3 root 3, and the y is 3. And you now have it's a lot of 3s. So many 3s. Yeah, 3 3s. Does that make sense? All right, try 2 and 3 for me. Be careful with your signs. Check in with each other. Are we...
300.
Oh.
Are you guys all in agreement that radians are better than degrees?
Oh, yeah. I was at 5,000.
What's your ordered pair? Oh, yeah.
You guys agree? You got them both? All right, give me another minute here, guys. We don't like... Yeah, I don't like degrees either. So just go, okay, I don't want it as degrees, and I'm making it 5 pi over 3.
Yeah, because 2 seconds here. So 30 degrees. That's the only way I remember it. I remember the 4 cardinal points and then just add.
So you're like, well, that's this far. Okay.
So for like the case of degrees, because you are turning it into the like root 3 or 2 like that, does it really matter that it's 5? It is positive 3 for remembering. You like what can I think? 5. Does it really matter that it's 5 pi over 3?
It only matters as far as you have to understand what quadrant it's in, so you don't mess up the sign.
Yeah.
So this is one.
But the ordered pair is the ordered pair. Like,
Yeah, it does.
my brain just doesn't think as quickly in degrees as it does radians.
My brain just doesn't think quickly.
Well, there's that.
Yeah.
All right, check your answers. Yay? Yeah? I'm very proud. Yay? Okay. Questions? It's okay if you didn't get it, just ask. We'll figure it out. Which one are you talking about? Oh, below it? You guys don't have these graphs, right? I took them out.
Take your phone.
No.
We don't have them.
Yeah, you're not supposed to have those. I was having issues getting the updated notes up here, so I have to cross some things out. Okay, so guys, that was converting polar to rectangular. We now have to go the other way. We have to be able to take a rectangular point and turn it into a polar point. So,
That's the graph. Those are our numbers.
you don't need those graphs. I know this one isn't what you have.
No, the graph is like all the script.
I don't like that.
Yeah,
You have to graph.
Whoa.
no, you don't need that. I took it off of there. I wasn't able to put the updated notes up.
That's what a polar looks like.
I know.
That's what I see when I see
Yeah, Ada.
Can you try to grab a side graph, really?
You want to see like what they actually look like?
How do you make
There's no.
Side. I'm gonna show you. I'll show you on a TI because that's what you're gonna use.
If I bring you around during that test,
Ooh, that's fun. I like that.
I'll just
Can I have a
stand
minute?
there and someone.
Extra 1.5 grade food.
Yeah, right. Oh, I got one shot at this. I have one shot. I'm decided I'm going to study now. It's keep going.
Yay!
Oh my gosh.
I kept promising them, oh, I'm gonna get it there. I'll do it exactly. Don't worry.
Guys, do you see on your calculator modes here, we've got FUNC, which is function, parametric. What do you think POL stands for?
Polish?
Ooh, not Polish.
Is that last one?
Sequence, yeah, sequential. We don't use that. If I change it to polar, look at my y equals. Oh.
What?
Wait.
Oh,
So why is data?
Wait, so how do you change it?
In your mode.
oh no. Oh no, what is this?
Alright, we did it.
What are you doing?
What?
What?
No.
That's like what you're gonna be graphing. Those are the pedals.
If it's supposed to be 4 modes.
Is this a rose?
Wow.
Oh, are these roses?
Yeah.
Oh.
Yes, but depending on if it's sine or cosine determines what it's symmetric
So
to.
all-
There's lots of really interesting patterns to
So
make
all
it.
those doodles on
What's the
all my
weirdest
tests
Are gonna
actually
matter, yeah.
No.
Sure, if you go to mode. I went back to radians because and then polar, just arrow over and highlight polar. And then when you go to your y equals, it'll be r equals. And we'll do lots of different things. These are just a couple of different. If I change it to sine.
So what makes
5
it a rose?
theta. The way the setup is there with the coefficient.
The coefficient?
Yeah.
So we're
We'll do other things that have like pluses and minuses in them. We might have like 3 plus 2.
Oh, we have it in radius.
Do you see this little like dimple in here?
Is it apple?
We're gonna learn different things where
There's dimples.
we're gonna learn dimple, inner loop, convex. I'm forgetting one.
Why does
Yeah.
cosine 4 results in like a 3?
I hit zoom trig also.
It's like, I'm gonna get a unit circle tattoo. I'm gonna get a.
So guys, that's an inner loop. See how that? Okay.
How do I get this?
How do you get what? To plot? So hit zoom and pick trig. Zoom trig.
Spiral?
Okay.
I've done something.
If we make a piece of art,
It's not a spiral.
can we get an A?
Is this spiral like a lava?
There's some other stuff. Yeah, it's hard to grasp a spiral sometimes.
Please?
I made the lips.
Did you get it, Nate?
Yeah, I plotted something.
You plotted something. Okay, good. So you're gonna learn lots of things. We have a whole day where there's pluses and minuses here. We have a day where there's not, and these graph different things.
With my hand, right? Or...
So what's
Yes, yeah, you're not going to be graphing these with your calculator, but your calculator can do that, and we'll graph over specific windows too. So then you'll only see like a portion of the graph. So you have to understand what you're doing very well to be able to graph the right portion of the graph.
So we're graphing on steroids.
Yeah, pretty much.
Nice. So if I get on steroids, that'd be
No, that will not help.
Maybe I should go on steroids and learn this.
No. Okay,
I like
so before that's like the running part. We must walk today, where we can like plot points and
It's a
convert
crawl
points.
day.
And yes, it's a crawling day.
all day.
All right. So to convert from rectangular to polar, you first have to plot your point. So where is 2, -2? Fourth quadrant. There we go. That's what I'm looking for.
Okay.
2, -2. Okay. We're back to drawing little triangles again. That's a 2. That's a -2. What we're looking for is the r and the theta,
Oh wait.
right? And then if we can find r and theta, then we've converted it to polar.
Law of science.
So how can I find r? Pythagorean theorem, right? 2 squared plus -2 squared equals r squared.
Square root of 8. 2 root
2 root what?
Sorry, 2 root.
Okay. All right, we've got our r. That's one piece. Okay.
No.
You are given x and y, right? You know the x is 2, the y is -2. Sine, cosine, tangent. Which one uses both the y and the x? Tangent. So tangent of theta equals y over x.
Oh.
So tangent of theta is -1. What angle am I talking about?
It's an over 4.
It's an over 4. There's a lot of ways you could
But
say
there's
it.
2.
Okay, so I want the one in the fourth quadrant. I could do 7 pi over 4. What's another way I could say it? Yes, -pi over 4. Either one works.
You know your unit circle? Yeah.
So your coordinate is 2 root 2.
Value gives you the value of -1.
If you wrote -pi over 4 there, that's great. Okay,
This is not enough room.
I'm sorry. I tried to make more room and I didn't make
It's alright, it's better than some other classes.
Yeah.
Wait, this
Where they give me no
So
room.
which one is the fourth
you
quadrant?
cross out
So your exercise.
So I wrote a different problem on yours. What does yours say? It doesn't say these decimals.
-3, comma root 3.
-3. Okay, perfect.
Oh yeah, I have that one too.
Excellent. All right, guys. Try to do that for 2 and 3.
I got it.
Oh,
You got boom. Alright, you got all of it.
Well, what's negative 2 divided by 2? Because I just put the y over x and then I simplified.
Oh, you have to be on the right way.
Oh wait, and then
Oh, no, right. Yeah, no, it's 4 minus.
Alright, I got 2 over 7 5 6. Not 2 over 7. That's 2. Let's see. Either of us could go there. So we're here, right? What? So we do y over x.
Hey, what did you do? No. You want the left side? Wait,
Are we ready? Not quite? Okay.
You're talking about playing song. Hey, yeah, I saw this. Hey, take 5.
Y or the y over x. It's an offset. I had to write.
oh, so you have to choose.
Yeah, the negative thing that we did, but it was negative.
Okay. The negative 1, negative root 3. What'd you get for your radius? 2. 4 pi over 3.
What?
Okay, or you could say 2, negative 2 pi over 3. Or, guys, think about this for a second. What if your radius was negative 2? Because it could be, right? We could go negative 2. What would you tell me then for your angle? Good question. Yeah, think for a minute.
Oh, wait, just get 2 pi. Yeah, 2 pi. No, pi.
Yes. Or no, no clapping required. Thank you. Negative, right? All of those are acceptable.
Oh. 2 and then ask pi over 3.
No, because that would take you to the first quadrant.
Why can't I be in the first quadrant?
Oh,
Because your x and y are both negative. You're in the third quadrant.
That plays into account.
That's why I want you to plot it first. That's why step 1 is plot the x,
Oh,
y
that was an
point.
actual step.
Yeah, see up
Oh, I
here?
thought that was optional.
See this? Plot the point.
I don't think math.
I mean, you don't have to plot it, but it helps so much with visualizing like where the angle is if you plot it. Maddie. Yes. So you have to. Hey guys, up here. Guys. Okay. Your time's now up. The step 1 that I did first, and the first one I listed, is plot the point. You need to do that so you can visualize where this point is, okay? Because you're right, you get 2 different places for tangent being positive, what was it, root 3 here. Because if you're just doing the tangent of theta equals root 3, you get a first quadrant angle and you get a third quadrant angle. You need to know which one of those you're using. If you look at your point, I've got a negative x and a negative y. Like, I'm in the third quadrant.
So can I, like,
so there's always going to be.
You don't have to draw it, but I need you to, like, know where you are. Okay? Does that make sense? Yeah? Okay.
I got all of them right.
Okay.
Tangents.
You don't have to. Once you've found R, if you want to do like sine or cosine, you can. But tangent, you were given X and Y, so tangent's easy to do there. But it's up to you. No, because the whole point is you're converting from rectangular to polar, so you have to have the X and Y. All right, guys. Number 3, what'd you get for your radius? What is R, guys?
Oh wait,
2 root 3, yes.
I was looking at the wrong.
And then this is a second quadrant angle, right? Okay, so what'd you use for theta? Theta. 5 pi over 6.
Let's go.
Okay, or 2 root 3 negative what?
7.
Okay. What if I made it negative 2 root 3? Negative pi over 6, good. Or positive 11 pi over 6, okay? I know it's harder for your brain when you start over on the negative axis, but it's good to exercise your brain. You're stretching your brain muscles.
Yeah, this is the first class of the day. I need to.
Okay, good question. So the question is, would you have to put all of these on an assessment? I might say, give me the ordered pair, your R has to be negative and your theta has to be positive. Or R is positive, theta is negative. Like I might give you specifics on how to get it. No, but we are going to finish. All right, questions on converting? Can you convert to not honors? Okay, this on yours says stuff we know, right? Does it?
Yeah.
Okay.
We know.
Okay. Not much. You don't know a whole lot yet. It's day 1 of polars, guys, so we should be able to fit everything you know in that little box. What we're going to do now, so we've converted points back and forth. We're now going to convert full equations. So we're going to start with a polar equation and convert it to a rectangular equation. The weird part with this is like, where do I stop? Okay? Technically, if you have X and Y in your equation and no longer an R and a theta, you've converted it. What I'm usually going to have you do with rectangular equations is if it's a conic, write it in the form of the conic.
No.
Just circles, basically. Okay. X squared plus Y squared equals some number squared. That's
I thought you said we
I
never
don't
would have
know.
to break that.
a little bit.
You lied.
Maybe amounts. I said I'm not going to like assess you on conics specifically again.
I think you pulled the 8 and skin.
Nope. All right. So let's think about stuff we know here. What does X equal? It does not equal heavy stuff. All right. R cosine theta. What does Y equal? Okay. What about X squared plus Y squared? R squared. So would you agree then that the square root of X squared plus Y squared is R? I know we didn't really do that one yet, but
Yeah.
yes. Now, if I have the square root of X squared plus Y squared, is that just X plus Y? You're like, oh no, it feels like yes, but no. Is that equal to that?
No.
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 Right.
No, it's like, yeah, exactly.
Is that equal to
The square root. Square root.
no? Square root of 13 does not equal 5, right?
Exactly.
Yeah, you can't take square roots of individual terms. Under a radical, it has to be a square root of a whole factor that you can pull out. Okay. So we would not be doing any other simplifying to that. If you have square root of x squared plus y squared, that's just what it is. Okay, so I'm going to walk you through the first one here. R equals 4 sine of theta. Okay. I could substitute for the r, but I can't substitute for just sine of theta. I need it to be r sine of theta so that I can substitute. So what I can do is multiply both sides of my equation by r. So I'm going to get r squared equals 4r sine of theta. We're converting to rectangular. Because can I substitute for r squared? X squared plus y squared. Can I substitute? I'm going to leave the 4 there, but can I substitute for r sine of theta? Yeah. What is it? No, what's r sine of theta, guys? Y. Okay. All right. So technically, it's no longer polar. It's now rectangular because I've just got x's and y's. But we have to do a little more work with this because, guys, this is the equation of a circle. Okay, so I need more room.
Are we gonna have to do some functions?
We're gonna have to do your favorite thing called completing the square.
I still don't know. I'll never remember.
All right, all I did, I moved the 4y over, I left a little space, and I put equals 0. Okay, everybody with me on? I've done too much there.
$10.
No.
Why is it always completing the square?
So the 4, it was there. And then do you see that r sine of theta is y? Like over here.
Oh, okay.
Yeah, so I just substituted for that. Okay. All right, so to complete the square, I know some of you still don't get it. The x squared we don't have to do anything for. It doesn't have an x term, you're done. The y, you take the b term, you divide it by 2, and you square it. What do I get? I am adding 4 here, I am adding 4 over here. Okay, I completed the square. That y squared minus 4y plus 4. That is y minus 2 quantity squared. Do we see it?
Wait. How do you have
It is
a
bad.
Wait, no, never mind. Real question.
All right, guys, you need to tell me, hey, that's a circle.
You have to
Where is the
know.
center?
Oh my god.
Oh,
Century like 0 positive.
Why is it
0.
November.
Why is it minus 4?
It's a positive 4. It's just a weird looking 4. Sorry, guys. I just wrote a weird 4. Is that better?
Radius.
And yeah, what's the radius?
How do we find the center?
The center is what makes each
Oh,
of these 0. So like that's just 0. This 2 is 0.
okay, and then the radius is the square root of the other side.
Yes.
that's crazy.
I remember kind of.
Guys, circles are the only ones I'm going to ask you from mechanics. I'm not going to be like, oh, don't you recognize that that's a hyperbola? And tell me where. Like, no, we're not doing that. Okay. You will see circles. Some of these are not anything, though. Like the next one we're going to convert, you'll see it's not a circle. It's just a thing. Yes. Okay. So let's do the next one together, too, just to make sure we're okay. Are you having that moment? That's a happy moment. All right. I know it says you try, but let's us try.
We got this.
Do you want to try?
No.
Yes.
It's actually easier than the last one. Because you just substitute and then you're done, guys. Okay.
That's it. I can't do anything with this. Great, I'm done.
Wait, this is
Is it like kind of long?
This one? Like a long answer. Yeah. But not a lot of work to get there.
Yeah. Yeah, no, between 2 steps.
Yeah, it's like 2 steps. You like it when they're not circles, because then you don't have to do more.
So I didn't even recognize them as circles. Like,
You'll get better at it, because what we're going to do next class, you'll recognize that that polar equation is a circle from the beginning. You're going to be like, oh, r 4 sine theta. Like, I know that's a circle. It's a circle centered on the y-axis, radius 2, like, x minus h quantity squared plus y minus k quantity squared equals r squared.
wait, so is the first example a circle in the polar?
Yeah, like here, I'll just show you.
But then wait, why is it not a rose? Is the rose like parentheses?
And a rose had a coefficient on the theta.
Isn't that
So this is technically a rose with 1 petal.
oh, but like we call it a circle. I see. That's why I was like, isn't that wait?
Yeah.
Why is it only 1 petal? Because
it wasn't.
Yes.
Yeah. So if it was like 3 theta, you'd have 3 petals.
Petals? I see. Okay.
Yeah. Okay. Whereas this one, this sine of theta plus 1, like.
Oh, maybe.
What's like a complicated rose?
Roses actually aren't that complicated. Like, it's a thing, but it's not something you graph normally on a rectangular. It's called a cardioid because it looks like a heart. Like it's got the little. It's a good Valentine's Day graph. Like a cardiac, yeah. I know. All right, let's look. Did you multiply by r first? Okay. Did we get x squared plus y squared equals y plus?
what?
I did that. Yeah.
That's it. Woo! Okay. Last thing we got to do is convert the other way. So from rectangular to polar. Okay. You don't have this box over here. That's fine. And I think I wrote in your directions solve for r, right? Is that on your paper?
Oh,
Okay. When you're converting to polar, that's how you know you're done. Like you substitute in, you get rid of the x's and y's, and then you solve for r. Okay? Ariel, you with me?
Yeah, you don't have anything in
R,
mind.
exclamation mark.
I would never.
There we go.
R factorial.
Yes.
Are you? I don't want to do that.
All right, let's do this one together. So the 4 I leave alone. What do you think I'm going to substitute for x?
R sine theta.
Our cosine theta. X is cosine. And then for y, I'm going to substitute.
R cosine.
Okay. We okay there? All right, so I've got 4r squared cosine sine.
oh, you put 1 on.
I took r times r. All right, I said you need to solve for r. So what would you guys do? By a lot of stuff, right? So r squared equals 9 over 4 cosine sine.
Yes.
Okay.
So we have to rationalize.
You take the square root. You do not have to rationalize. What do you need to remember when you solve with a square root? Okay. What's the square root of 9? It's the square root of 4. And then the cosine sign is still under the square root. Okay, that is an acceptable answer. let me show you something else we could have done. Because I'm not making you. We're getting to the point of the year where I stop making you rationalize. We're almost there. Apparently we're there today. You know, with the other trig stuff we've done, you'll still rationalize. When we get to the calculus stuff, I don't make you rationalize because you don't have to rationalize in AP Calc.
Wait, is
So
the plus or minus before the fraction or after?
either way, means the same thing. Okay, let me show you another way we could have looked at this. So from this step of 4r squared cosine theta sine theta equals 9. This could have been rewritten as 2r squared times 2 cosine theta sine theta equals 9. Does anybody see anything? That is. You.
It's just written here.
What?
Do we see that?
Why would I do that?
Okay. Why would I do that? Good question. So sometimes the way I'll give you these on an assessment, it might be a multiple choice. And I'll say it converts to which of these. I might not put the plus or minus 3 over 2 square root of cosine sine. I might put this one. So you have to be able to like just keep messing with it until you see that. They're hard as multiple choice questions.
Wait, are you gonna have multiple choice on the cumulative?
Maybe.
Would you simplify all the way like solve for
I
r?
don't like.
Yeah, I'm gonna keep going. Oh, yeah.
There's like a whole top page.
Oh, is that homework?
Oh yeah, we're just ending this page, guys. The other is like practice, but and you can stop there. It's not exactly like more pretty than the other one, right? It just is.
It just looks like the other one, but
You just can't do it.
Yes, you just be aware that there are like multiple ways you could write these. Okay.
no, if it's
If there is like two sides or the double.
Yeah, it's good to substitute. All right, guys, one more. Do you want to try? You try or we try?
I want to try.
You try. Okay. Last one, guys. The other part that's on there is just practice for you. So this is the last part of our notes. Yeah, so you would want to do like
I'm allowed to do that, right? Okay.
this square, like that.
Yeah.
Okay.
I was really
Nope.
Oh.
You should get R equals 2 different things, guys.
X. X.
I don't think you distribute that well. I think it's square that's well.
Like, I'm not feeling it.
I got a few things where I feel like this is very hard to solve.
Well, let's see where we got to. So r squared sine squared theta equals 2r cosine theta. Everybody okay with that?
Yes.
Okay. When you're solving for r, guys, just like on your trig stuff, You cannot divide everything by r because you lose solutions, okay? What I can do is move everything over and then factor. Oh, yeah. That came up again for a few of you on that Skill 7 reassessment. Some of you were dividing by things and canceling them out. No, factor.
So what if you did the square root in the first?
But then you have the square root of r left. So you can't really solve for r if r is in what r equals. Do you see what I mean? Oh. That's fine, but then you have an extra x that you have to deal with.
Yes.
Right, like you still have an x. So then did you plug in the cosine thing, or did you? I mean, you should still be able to get there that way, but you are taking the more challenging route. So I should get r equals 0. And then, I didn't make that a thing. You get this lovely 2 cosine theta over sine squared theta, which you could do other things with, like 2 cotangent times cosecant, things like that, okay? So just be aware of those, but no. Like that would work too. This r equals 0. Where is r equals 0 if that's all you're given? Right? It's kind of like the 0, 0, like the origin, right? We call it the pole in polars. It is. Okay. All right, guys, we made it. Woo-hoo. Okay. You do barely is right. We do have math space. I am making it available right now. Hey guys, next class I'll pass back your tests.
God, I'm so stupid. It's fourth period. Oh,
What is the first?
It's fourth period.
Is that like?
Yeah.